All right, so we have 14.4, part 2, I'm calling it, which is instantaneous rate of change. Essentially, in this part of 14.4, we're going to take the procedures that we learned last week and apply them to some word problems. So last week we learned about the word derivative. So remember, a derivative is a slope at a certain point, right? So if we're talking about a graph that maybe looks like this, the slope here is going to be different than here, which is going to be different than here, etc. Right? So the derivative is the slope at a certain point. We could also call this the instantaneous rate of change, right? So right when you were learning what slope was, back in algebra, we always called it the rate of change. It's the change that's happening. So if I say find the instantaneous rate of change, that's another way of saying derivative, which is another way of saying slope. Now, I always say in calculus, one of the hardest things, in my opinion, is all of the vocabulary. We have tons of vocabulary that all means the same thing, right? Finding the rate of change is the same as finding the derivative, which is the same as finding the slope. So there's just a lot of words that you need to know. What does that mean? What is that asking me to do? Now, the instantaneous velocity of a particle, so if s equals f of t denotes the position of a particle at a time t, then the average velocity of the particle from c to t is the change in the position over the change in the time. So we find that by doing f of t minus f of c over t minus c. Now remember, this is just a slope formula, right? Y minus y over x minus x. So we're just finding the slope. What velocity means is speed. So we're finding the instantaneous speed of the particle, which is still found by using derivatives, right? So the speed is coming from the derivative of the function. So if we want to find the instantaneous velocity of a particle at time t, then we're going to find the derivative. Remember the little tick mark there, it means prime. So f prime of c is found by using the limit of this formula that we have up here, right? So this formula here, we're going to do the limit of the slope formula, which this should look very familiar to what we did last week. I'm just changing the letters a little bit, right? Last week, I think we had X's and T's and stuff and such instead of T's and C's, but it's the same thing. So in number 1, we have the volume of a right cylindrical cone of height 9 and radius r feet is found by the formula volume equals 1/3 pi r squared h. If r is changing, find the instantaneous rate of change of the volume v with respect to the radius r at r equals 2. So we want to find what is the rate of change, what is the slope at r equals 2, right? So if r is changing, so if we had a cone and it had r equals 7 and then it's changing to r equals 3 and it's moving all around, right? It's getting bigger and smaller and bigger and smaller. We want to know what is the slope, what is the instantaneous rate of change at r equals 2. So we're going to do the limit as r is going to 2, r is changing to 2, and that's going to look like v minus v of 2 over r minus 2. So the y values minus the x values. Now v is this guy, but it specifically said that our h was 9. So v is going to be 1/3 pi r squared with a height of 9, which gives us 3 pi r squared, because 1/3 of 9 is 3. So we have 3 pi r squared minus, now v of 2 means we're plugging in 2 for our radius. So 1/3 pi 2 squared, but the height is still 9, right? That's not changing. The height isn't changing, just how wide the cone is changing, not the height of the cone. So we've got 4 times 3 will give us 12 pi. So minus 12 pi all over r minus 2. So now we need to factor, because I can't plug 2 in here yet because that would give me 0. So we could factor out a 3 and we could factor out a pi. So if we factor out a 3 pi, that leaves us with r squared minus 12 pi divided by 3 pi gives us 4. all over r minus 2. Well, this is the difference of squares, so now we can factor by difference of squares, so r minus 2, r plus 2, all over r minus 2. Oh look, our r minus 2's can cancel, awesome. So now that those have canceled, we can plug in our r is 2. So 3 pi times 2 plus 2, 3 pi times 4, 12 pi. So the instantaneous rate of change when r is 2 is 12 pi. Now, number 2, we've got multiple parts on number 2 here. So we've got A through H. There's a lot of work that's going to be done on this problem. So in physics, it is shown that the height, S, typo, of a ball thrown straight up with an initial velocity of 80 feet per second from the rooftop that is 96 feet tall is shown by this equation. Okay, so S is the height, T represents time, where T is the time the ball has been in the air. So the ball misses the rooftop and on its way down, it eventually strikes the ground. So what's going on here is that we have this situation where it starts out at 96 feet, right, on the top of a rooftop. We throw the ball up, and it's going up, and then it's coming down, but it doesn't go on the rooftop. It kind of went up and over, and it eventually will strike the ground. So this is kind of what our curve looks like, and this curve is represented by this equation here. So it wants to know in part A, when does the ball strike the ground? So if we think about what does that mean? When, that means I'm finding out what is the time, right? T equals what? When is the ball going to strike the ground? Well, when something strikes the ground, that tells us that our height is 0, right? It's no longer above the ground, so that means our height is 0. So that means height, remember, is S. So that means we're going to do 0 as the height, and we're trying to figure out at what time does that happen. So we have 0 equals negative 16t squared plus 80t plus 96. So we could solve this by algebra or by using our calculator. I'm going to do algebra first, and then I'll show you our calculator. So using algebra, we would factor. So I'm going to take out a negative 16. That leaves us with t squared. 80 divided by negative 16 is negative 5. 96 divided by 16 is negative 6. What multiplies to negative 6 and adds to negative 5 would be negative 6 and positive 1. Set each of these equal to 0. We get t equals 6 and t equals negative 1. Oops, I don't know why I wrote negative 6. Negative 1. So what that means is at time negative 1, right, if I were to go over here, it also strikes the ground. But we're not talking about negative time. That doesn't make any sense. So that's not a possible answer. So our only possible answer here is 6 seconds. So it's going to take 6 seconds for us to throw the ball up and for it to hit the ground right here. That's taking 6 seconds to hit the ground here. Okay, now on our calculator, if we were going to use our calculator, what we could do is we could go to our y equals negative 16x squared plus 80x plus 96. We go to our graph here. There's our graph, and we would want to find the time right here, so we could do second trace, find the 0. Oh, there it is. So left bound is first. Left bound, right bound, enter. Oops. Let me try that again, sorry. Okay, left bound, right bound, enter. There we go. X is 6, Y is 0, so at 6 seconds, the height is 0. Now I wanted to show you the factoring because I know right now we are on our stay-at-home order. So you guys are at home doing this, so you can use your calculator. But when you take calculus next year, this is going to be on the non-calculator part of your test, and you need to know how to factor. This is all skills that you need to know how to do without a calculator. Okay, now B here is saying at what time will the ball pass the rooftop on its way down? So we're saying if it's at 96 feet tall and it's going up, it's going up, it's going up, it's coming down, we want to know at what time right here is it passing the rooftop before it hits the ground at 6 seconds. Does it take 2 seconds to get back down to the same height? Does it take 3 seconds, etc.? So that means the height is 96. So this time 96 equals negative 16t squared plus 80t plus 96. We need to factor, which means we need to multiply the 96 to the other side, which in this case it happens to cancel out, which is nice. So that gives us 0 equals, we can factor out a negative 16 and a t this time, which gives us t minus 5. Set each of these equal to 0, that gives us t equals 0, t equals 5. So time equals 0, it's at 96 feet. Of course, that's where it started. At time 0, it's at 96. And then it takes 5 seconds to get all the way over here at time equals 5 seconds. Okay, so we're going to keep going. Now C. C says, what is the average velocity of a ball from t equals 0 to t equals 2. Now notice it doesn't say instantaneous, it says just average velocity, right? Not instantaneous velocity. So all we're doing here is finding the slope from time equals 2 to time equals 0. So we're going to do s of 2 minus s of 0 over 2 minus 0. So we do have our calculator, so why not use it? So negative 16 times 2 squared plus 80 times 2 plus 96 gives us 192. So 192 minus f of 0 is 96 all over 2 minus 0. So 192 minus 96 is 96 over 2, which gives us 48 feet per second. So over the time from t equals 0 to t equals 2, the average speed is 48 feet per second. So that's how fast it's moving, is 48 feet per second on average, right, between time of 0 and time of 2. At time 0, it might be moving a lot faster. At time 2, it might be moving a lot slower. We don't really know, but on average, this is how fast it's moving. Okay, now part D here is where we're getting into our instantaneous velocity. So this is just our average speed over a period of time. This is going to tell us at time blank, it's going this fast. Okay, so not an average, but at a specific time. Now in order to do that, we're going to use our limits. So we're going to do the limit as c is approaching t, because we're going at time t. So that means we have to do s of c minus s of t all over c minus t. Okay, c is first, t is second. So s of c, now remember s of c was the negative 16t squared plus 80t plus 96. So if I'm doing s of c, that means I'm replacing t with c. So that gives us negative 16c squared plus 80c plus 96 minus s of t, which is this, negative 16t squared plus 80t plus 96 all over c minus t. So our first step here, we'll distribute this negative symbol. So we have negative 16c squared plus 80c plus 96 plus 16t squared minus 80t minus 96 all over c minus t. So our 96's cancel. Now let's combine our 16s and our 80s here. So we have negative 16c c squared plus 16t squared plus 80c minus 80t all over c minus t. So we can kind of treat this now as let's group these two together and let's group these two together and factor, right? So like factor by grouping. So we can factor out a negative 16, which leaves us with c squared minus t squared because I took out the negative. So change this to a positive to a negative. And then here I could take out an 80, which leaves it with c minus t all over c minus t. Now this is now the difference of perfect squares. So now we can factor out a perfect square. So negative 16, c minus t, c plus t, plus 80, c minus t, I'm running out of room here, all over c minus t. Now, because this has a c minus t and this has a c minus t, all three of these can cancel out. Now, if there was no c minus t here, then we're not allowed to cancel those out. But because it's in both of these, we're allowed to factor out or cancel out all three. So that leaves us with negative 16 c plus t plus 80. Now remember, we're doing a limit as c goes to t. So that means I'm changing c into t. So I'm going to change c into t. So t plus 80. Well, that would give us 2t plus 80. 16 times 2 gives us negative 32t plus 80. So what is this, right? You're probably thinking, Ms. Peck, why did I do all of this work? This is what we call the derivative function. So this is s prime of t. Now what this does is it gave us an equation to find the instantaneous velocity at any moment in time. So this is a formula, it's called the derivative, right? But this is an equation specifically, there we go, sorry guys, for this equation that's going to tell us the speed at any given moment. Okay, so for example, in part E here it says what is the instantaneous velocity at t equals 2, right? So when we have, remember we had our situation here where this is 96 feet tall, it got tossed up, it's coming back down. We want to know at time equals 2, how fast is it going up, right? Or is it going down already, right? We want to know how fast is it going at time equals 2. So we're going to do s prime of 2. So we're going to plug 2 into this equation. Negative 32 times 2 plus 80. So negative 32 times 2 plus 80 gives us 16. So it's moving 16 feet per second. So at time is 2, it's going up because this is positive. That tells us it's still on the upward trend. So it's moving at a rate of 16 feet per second at time 2. Not at time 2.2, not at time 2.3, but at time 2, it's moving 16 feet per second. Remember up here, between 0 and 2, it was moving this fast on average, right? Not at time 2, but on average, between time 0 and time 2, it was moving 48 feet per second. So we know that at time 2, it's starting to slow down. Because if on average it was moving 48, and it's now only moving 16, that speed is starting to slow down, which tells us it's starting to get up to the top, right? It's kind of was moving really fast, and now it's slowing down because it's at the top, and then it's eventually going to go back down, and it's going to go really, really fast on the way back down. Because of gravity, it's pushing it down, right? So part F wants to know when is the instantaneous velocity of the ball equal to 0. So essentially we want to know when the speed is 0, that's at the very tippy top. Okay, that's when we have a speed of 0. It's at the very tippy top, right? It went really fast up, now it's at a speed of 0, and then it's going to move back down. We want to know at time what? So that means instead of us plugging in 0, we're saying the answer is 0. I want to find the time, right? I'm solving for time. I know the speed is 0. So subtract the 80, divide by negative 32, negative 80 divided by negative 32. gives us 2.5. So it took 2.5 seconds for it to reach the very top. Okay, it took 2.5 seconds. It has a speed of 0. Last two questions here. So G. G says, what is the instantaneous velocity of the ball when it passes the rooftop on the way down? So if you remember earlier when we were doing this problem, we said, well, when will it hit this 96 feet? And we solved and we said that, oops, that's the wrong page. We said that it would pass the rooftop on the way down at 5 seconds. So we're going to find at t equals 5, what's the speed, right? Velocity means speed. So we're going to do s prime of 5. So negative 32 times 5 plus 80 gives us negative 80, and it's a speed, so feet per second. So at 5 seconds, it's moving really fast. It's going negative 80 feet per second, which tells us it's on the way down. It's going down at a speed of negative 80 feet per second at time 5, right? Because at time 2, it was moving 16 feet per second in the upwards direction. At time 5, it's moving negative 80. Last question, when is the instantaneous velocity of the ball when it strikes the ground? So once again, let's think back. We said that when we had our equation, it hit the ground at time equals 6. So we're going to do s prime of 6, right? And that was the very first question we did, in case you're wondering where I got the 6 from. We said that it hits the ground at 6 seconds. So negative 32 times 6 plus 80 gives us negative 112 feet per second. So when it hits the ground there, it was moving at a speed of negative 112 feet per second. And that is our word problems, guys.